Is it
I got
is it up?
QCU plus PO4 yields What?
I think that's good. Yes,
Yeah,
that's
that's
good.
good. Thanks.
Yeah, so we'll just find that highlight so that way you go to each one C PO4.
Yeah, you don't invest for Jennifer's counting these days.
I know.
Today is off day. I don't get it.
I don't get it.
October 10th. Oct 10.
10.
Yeah.
Oh, that was good.
Yeah.
Really?
Wow, that was good. She did some homework on that one.
The whole one there? No, because single dollar. Yeah. Yeah, Octane was the better. Oh, what's the find the message of certainty?
I have the same equation. How many multiples?
Wait, why hey, that's mold. Ammonium phosphate.
Multiply by 0.1 is like divided by 10, right?
Yep.
Yeah.
How would you divide?
I don't know if you're seeing that.
Josh.
How are we doing on part B? Are you good with the mass of precipitate?
Yeah.
Once again, I find it a little bit more straightforward to do the stoichiometry from the overall full molecular balanced equation than I do doing this. Which way did you do it? You did the full? If you do the net ionic equation, how many moles of copper are you starting with? We start with 0.04 moles of copper 1 sulfate. Notice how every copper 1 sulfate has 2 coppers in it? You don't have 0.04 moles of copper ion, you have 0.08 moles. You've got 0.08 because every one of these has 2 coppers in it. You'll wind up with the same limiting reactant. So let's see, for the phosphate we got 0.025. And there's 1 phosphate in every one of these molecules, so 0.025 moles means you're going to have 0.025 moles of phosphate. But over here, 0.04 moles of this means you're going to have 0.08 moles, twice as much of copper, as moles of that whole compound you have, because every molecule has 2 coppers in it. Catch that? So, either one is going to get you to the right limiting reagent. Yeah, again, this was 0.04 moles of the whole compound. But since every compound has 2 coppers in it, it's twice as many moles.
Oh.
0.08. To figure out the limiting reagent, it's a little bit easier to me to look at the net ionic because this is a 1:3 ratio. You need 3 times as much copper as phosphate. Do I have 3 times as much copper as phosphate? Yes, I have more than enough. So phosphate runs out first. The same thing is true up here, but it's not as obvious. 2:3 ratio. I need 1.5 times more of that than that. So I've got 0.025 moles of this. 1.5 times 0.025 would be 0.037. I have more than 0.037 moles of it. So once again, my substance containing phosphate runs out first. Am I talking too much and losing you? Yes?
Can you explain one more time why in the net ionic equation copper is 0.08 moles?
Did you think it should be 0.04? This number of moles.
Yeah.
Do we agree that copper sulfate had 0.04 moles? From the molarity and the volume up there, we calculate 0.04 moles of this compound. But the copper ion, every time one of these dissolves, you get 2 copper ions. So if I have 0.04 moles of this thing dissolved, I get 0.04 times 2 copper. That's where I got the 0.08. Renuka. I think it's way easier to do this from the net ionic than to go from the full molecular. So you can do it either way. Yeah, that excess ion, I think it's easier to see it from the net ionic. We need to practice this. It is essential that you start doing a few of the precipitation. There's a bunch of precipitation problems in the homework exercises, now that they're on the Schoology page. Do a few of them tonight. And don't do the Mickey Mouse ones. Like, there's some that are just like basic molarity problems. Skip those, go right to the section in the problems that says precipitation, and do some hard ones. Keep doing them until you get something challenging. So knowing the limiting reagent, I know all that runs out. The mass of the precipitate, we want that term right there. So 0.025 moles of phosphate times, it's a 1-to-1 ratio.
That's copper 2, right?
It's up there. So 1Q4.
This reverse this.
Okay.
Oh.
The molar mass of copper phosphate is 180 something, isn't it?
185.
It's 185. Okay. Thanks. I won't even go past the decimal. It's close to that. The molar mass of Cu3PO4.
It's 285. Yeah, 285.
Thanks.
We're only off by
So this is our setup for part B. 286? Okay, I can't do that one in my head. We probably could. 0.25 would be just dividing that by 4. So if you divide it by 4 and then divide it by 10, that would be the answer. So if you're looking at mental math, how to make this simple, if I got to do mental math for this, 0.025 is 0.25 times 1/10. So just take that and divide by 4, then divide it by 10. Or grab your calculator if you can and do it that way. Not if the if it's multiple choice questions, no. So you get what? 7.7 grams?
No, 7.1.
Okay, what was the difference?
I said like something.
Oh, point something. I thought you said 7.
Yeah, no, I said 7.1.
So what did you say then, those of you that calculated 7.1?
So it was just 3 sig figs.
Okay.
I know you go one past what you're adding.
Yeah, we're only allowed to have 2 sig figs on this thing. So, calculate the concentration of the excess ion after mixing. All the phosphate got used up. Yes? It's the limiting. It's all gone. Gone. Nothing. Copper, it was an excess. There's still some copper present. How much? Well, the copper ion concentration, this is just like what we did in the last problem over there. We started with 0.08 moles. How much got used? How much copper got used? 0.075. Yeah, because all that 0.025 moles got used, all that got used up 3 times that much copper then must have gotten used. So minus 0.075. Then divide by the total volume. Notice that we mix 2 solutions so the volume gets higher. 100 ml and 100 ml, so it's 0.2 liters. That's how we do part C. Now, yeah, there are times that it's easier to do the full molecular equation stoichiometry. There's times that it's simpler to do the net ionic. But the net ionic, you got stuff like this, where we had to double the number of moles of copper because there's 2 coppers on it. Now, remember at the beginning of the hour, I told you, hey, if you think you had a good handle on stoichiometry, I'm here with a big needle to pop your balloon, right? Does that make more sense now why I said that? Sorry, we have different humor.